Again, we have a rational expression and partial fractions is appropriate. I'm gonna go to the whiteboard to do it though, because it's gonna take a little bit of room to do it, all right? So let me go to the whiteboard and pull it up and write down the integrand, which was 2x minus 5. By the way, we're doing problem number 47. And it's 2x minus 5 over x cubed plus x squared. And what I'm going to do there is, factor the bottom. And it's 2x minus 5. That would be x squared. And that's going to be x plus 1. Well, this is kind of interesting to do because I realize it's repeated factors of x. So I'm going to say a over x plus b over x squared, and then c over x plus 1. With the LCD, pretty simple. The LCD is x cubed plus x squared, or if you prefer, x squared, x plus 1. I'm going to multiply both sides by the LCD, and you'll get this. You get 2x minus 5. When I say both sides of this equation over here, all right? And what do you get over there? You're going to get ax, x plus 1, plus b, x plus 1, plus c, x squared. Well, I'm going to pick easy numbers again. The numbers I'm going to pick is x equals 0 first off, because I think it's easy to do. You get minus 5. And what do you get there? Well, the first term disappears, the third term disappears, and you just left off with a b now. So b is minus 5. All right, let me take another easy number. I'm going to say x equals minus 1. What do you get there? Minus 7. And if you chose minus 1, the first two disappear, and then you get c. So now I know c is minus 7. Now certainly I don't know a yet, so I need to pick another number that's easy for me. I'll say 1. And what do you get there? Well, you get minus 3. And let's see what you're going to get there. If I pick 1, I'm actually going to get 2 times a. And if a is, I don't know a, so it's 2a. Let me make sure I did that right. So 1 plus 1 is 2. Yeah, 2 times 1 is 2, 2 times a. I got that. What's the b going to be? It's going to be twice the b, right? Because 1 plus 1 is 2, and twice the b is minus 10. And then I get this c. It's going to be 1 times c, and what was c? It's minus 7. All right, a little more complicated, but I can do it. It's minus 3 equals minus 17 plus 2a. I'm going to add 17 to both sides, and I get 14 equals 2a, and a would equal 7 now. All right, so I'm ready to do my integration. I'll put down the integration again. The integration was 2x minus 5 over x cubed plus x squared dx. I'm going to write this, and let me just make sure I'm going to do this. A is 7, so I'm going to write down 7 over x dx. Right, I'm doing this over here. And the b was minus 5, so I'll write this over here, minus 5 over x squared dx. And last but not least, I got the c right. What was the c? It was minus 7. Right over here, minus 7 over x plus 1. So if I did that right, yeah, I did okay. All right, let's put one step at a time. And the first one's really not that bad. It's going to be 7 natural log, absolute value of x. There's going to be minus. I want to point out, I'm looking at a 5, but it's really, the integrand is x minus 2. So what do? I increase the exponent by 1, so it'll be minus 1, and divide by minus 1. What are you going to get? Plus. It's going to be plus 5 over x. Let's go to the next term. Not so bad. Minus 7 natural log x plus 1. All integration symbols are removed. I'll put the c down. Again, my recommendation is to look at the answer key to make sure you got this. Now notice in the answer key, I certainly see this, but what they did was they combined these two terms together, which is typical. Let me go through that for you. So those two terms are 7's in common. So what do you get? 7, using the rules of logs, it's going to be natural log of the absolute value of x over x plus 1. And this is important when you're multiple choice exams. You want to be looking around for the correct answer. And that's the answer that's listed in the key, by the way. And it certainly does look neater, but both answers are fine, by the way, if we're in a written exam. Thank you.